Hi guys, today we are going to continue talking about conic sections. In the earlier video we had talked about circles. Today we're going to focus on parabolas, and then we will table ellipses and hyperbolas on a later video. What is a parabola? So a parabola, straight definition is a parabola is a set of points in the plane that are equidistant from a fixed point and a fixed line where, okay, a lot of good stuff. Okay, so that fixed point is the focus. Okay, the fixed line, I'm gonna make it dashed, is called the directrix. Okay, so we want to graph all the points that are the same distance from that fixed point or the focus and the vertex. Okay, so this is distance 1 and distance 2. Those distances should be the same. Okay, I don't have an animation with me because I didn't get decimals ready, but then when we so all of those points will give us this beautiful shape of parabola. We have graphed parabolas before in the course. Okay, some parabolas opened up, some parabolas open down. In this case, we're gonna look at parabolas that open to the left or open to the right. Okay, I know I said it backwards, it's just I'm used to putting the one to the right first. Cool. All right, so let's do this. So let's go ahead and look at the standard equation to write a parabola. Okay, so the standard equation of a parabola with vertex at hk is, so in an earlier unit, way earlier in the course, we had talked about a vertex form. You know, a parabola or quadratic equation is said to be in vertex form if it looks like this: y equals, or if we use, you know, function notation, f of x equals a times the square of x minus h plus k. Cool. So this was called vertex form. Okay, but the standard way to write it is the following: we have square of x minus h is equal to 4 times a times y minus k, or we have square of y minus k is equal to 4a times x minus h. Now the question is, how can I tell if it's a parabola that opens up or down or side to side? Okay, well, to make that call, we look at where the square is. Okay, now this 4a is in my way, so I'm going to go ahead and ignore it. Okay, so if I ignore it, I notice that the square is on the x and the h is also in my way. So this kind of reminds me of y equals x squared. Okay, so if we have the square on the x from back in the day, that's gonna be the parabola that opens up or opens down. New to our life, let's go ahead and look at the second equation. So the 4a is in my way. Let me go ahead and cover it. The h and k are in my way. Okay, so in this case, I'm left with x equals y squared. So this kind of reminds me of nothing. It reminds me of nothing. It's just I don't know how else to phrase it. So in this case, if we have y equals x squared, that's going to be a parabola that opens up or down. I guess by cross elimination, if we have x equals y squared, then that's going to be a parabola that either opens to the right or opens to the left. The question is, how can we tell if it's gonna open this way or that way? So that is dictated by the value of a. For the ones that go up or down, if a is positive, parabola opens up. If a is negative, parabola opens down. For the parabolas that go sideways, if a is positive, the parabola is gonna open to the right, and if a is negative, then the parabola is given to the left. We have a lot of nice formulas which you can read, you know, pause and rewind, but I actually don't memorize these formulas because remember what I said before, I memorize what I have to, but I try to understand as much as I can. So I'm going to try to break this down to you to the best of my ability. Okay, so here we have a standard equation of a parabola with vertex at the origin. So these are the equations: x squared equals 4ay, and then y squared equals 4ax. So again, memorize what you have to, digest as much as you can. The 4a is in my way. Okay, so this kind of reminds me of y equals x squared. Okay, so I'm going to say the same speech. So like, okay, y equals x squared, so it's going to open up or down. So let's go ahead locate these things. So right here we have the vertex. This point right here, new to your life, that's going to be the focus. The distance between the vertex and the focus is going to be A units. That's a break supposedly. Sorry, I tried my best. Now this dashed line, that's going to be the directrix. The distance between the vertex and the directrix, you guessed it, should be the same, A units. Okay, so in this case, once you have the vertex, to locate the focus, you're going to go A units up, and then to locate the directrix, you're going to go A units down, and you do your horizontal line. What if you have a parabola that opens down? So let's go ahead, locate the vertex, and then to graph the focus, we're gonna go A units down, and then to locate the directrix, we're gonna go A units up. Okay, so let me go ahead, put V right here for vertex. Yeah, I shouldn't have done that, there's no space. Okay, what if our parabolas, you know, open sideways? It's no different. Okay, we have our vertex right there. To graph the focus, we're gonna go, if A is positive, you know, we go so many units to the right. That will be our focus. For the directrix, we're gonna go so many units to the left. Now, what if the parabola opens to the left? So here's our vertex. To identify the focus, we're gonna go so many units to the left, or you know, A units to the left. To graph the directrix, we're gonna go so many units to the right. Well, A units to be exact. Okay, and then we have the formulas right there, which you can memorize. But again, memorize what you have to and digest as much as you can. So in today's video, we're gonna do 1, 2, 3, 4 sets of problems, and that'll be our day. Thanks, guys. Give me a sec. Okay guys, so let's go ahead and do our first fun problem. So remember, we're going to do 4 fun problems and we're out. So the directions read, graph the parabola. Please locate at least 5 points on the graph. I'm so polite. Include the graphs of the vertex, focus, and directrix. Give the coordinates of the vertex and focus and the equation of the directrix. So in short, we want to graph the parabola, but we want a comprehensive graph. So this is why it says include the vertex, focus, and directrix. And it would be nice if you have at least 5 points. If you want to do 6 or 7, go for it, but 5 is the minimum. And then I also want you to tell me what are the actual vertex and focus. So for the final 3 statements, give the coordinates of the vertex and focus and the equation of the directrix. If you look at the problem, that part is phrased like a fill in the blank, so I would appreciate it if you put your answers there. So with that being said, it would be nice if we had a sense of what this should look like. So I'm going to cover up that -8, and that looks like y equals x squared. So I'm just going to say that this reminds me of y equals a squared. So remember, the standard equation of a parabola with vertex at the origin, that's what the book stresses. We have, what was it, x squared equals 4ay, or we had y squared equals 4ax. What I wanted to point out is this, which variable gets the 4a? It's the one that doesn't have the square. Okay, so in this case, the y doesn't have the square, so let's go ahead and put the 4a with the y. Okay, so in this case, this equation is of the form 4a equals y squared, but I jumped the gun, sorry. So again, when I cover up the -8, that looks like y equals x squared, and the equations that are of the form y equals x squared are going to be parabolas that open up or down. In order to make that call, we have to identify the value of a. So if a is positive, parabola opens up. If a is negative, parabola opens down. Now let's go ahead and find the value of a. So we have said that this equation should be of the form x squared equals 4ay. So I just switched the order. Okay, so this equation is of the form x squared equals 4ay. What's so special about the number 8? So the number in front of y should represent 4 times a. So we want to know what is the value of a. Okay, so we have that 4 times a should equal -8. Okay, y times something, y times something. We keep our cool. I mean, you can handle it. After we divide both sides by 4, that will give us a equals -2. because A is negative, then the parabola is going to open down. What I'm going to do right now, you totally don't have to do. You can just do, graph it. I'll spit out what I ask you to find. But I'm going to do a really rough sketch first, and then we're going to graph it. Okay, so the question is, what is the vertex? So the vertex is of the form HK. Now, our book just stresses a parabola centered at the origin. So you can just be like, yeah, vertex is at the origin 0, 0. But I want to show you why. Okay, so the vertex is of the form HK. Now, in terms of H is associated with the X. So I want to know what follows the minus sign. Okay, so let me go ahead, wrap up the X. What are we subtracting from X? Nothing. Okay, so the value of H is 0. K, that's associated with the Y. What are we subtracting from the Y? Nothing. Okay, so K is 0. Okay, so the vertex is at 0, 0. Let me go ahead, locate that right here. We have already established that the parabola opens down. Okay, cool. Now, what about the focus? Since A is -2, we're going to go down 2 units. I don't want to say absolute value of A, but we're going to go down 2 units. So 1, 2, that will give us the focus. And this will give us 0, -2. Let's go ahead, pencil it in. What about the directrix? So we're going to go 2 units to the other side. So in this case, up to 1, 2. And then we're going to do a horizontal line right there. And the equation is given by y equals 2. Why? Because it doesn't matter where I am on this horizontal line. The value of y is 2. So I think it's pretty neat. So if we can do a really rough sketch here before we're a little bit nervous, then we should be good to go. Okay, so we are asked to graph the parabola by locating 5 points. So let me go ahead and do my XY table because I need it. If you don't need it, I don't need it. The first point that I'm going to highlight on the table is going to be the vertex. I forgot to put the coordinates, 0, 0. Cool. Let's go ahead, locate the vertex. While we're at it, let's go ahead, graph the rest of the information. So the focus, it's 0, -2. Do you have to put the coordinates? It's a personal choice. We already did it right there, so it's really up to you. The directrix, let's go ahead and graph it. Do we have to graph it? Yeah, you do. Why? Because directions said so. Okay, so we want to graph it, and we want to include the graph of the focus and the directrix. Okay, give me a sec. Okay, cool. So that doesn't look too good. Let me go ahead and do it with my highlighter. Remind me to do it with the highlighter next time. Okay, fantastic. Okay, cool. So now the question is, should we just freehand it? No, we don't want a rough sketch. We want a really nice graph. Okay, so let's go ahead, pick either an X or Y value. Should we pick X values? Should we pick Y values? You know what? That's really a personal choice. What am I gonna pick? Well, in order for me to do a really nice graph, to have a sense of how wide this should be, I'm actually gonna pick values for like Y. So I want to pick Y equals -2. So that will give me a better sense of how wide this is. Let me go ahead, pick a value for Y. Let me go ahead, circle it to remind me that in this case I picked value for Y. So when Y equals -2, I want to know what is the value of X. So we have X squared is equal to -8Y. We pencil in a -2 for Y, so that will give us X squared is equal to -8 times Y, or -2. Last time I checked, product of -8 and -2 gives us +16. And when you square root both sides, that will give you that X equals +4 or -4. So when Y equals -2, we're going to have two possible X values. The first one being +4 and the other one being -2. Okay, so let's go ahead and graph them. So we have 4, -2. So from the origin, 4 right and 2 down. The other point, -4, -2 from the origin, 4 left and down 2. So that will give me a really good sense of how wide this is. Not like this not so nice graph, but it's okay. This was a rough sketch. Now, unfortunately, we are asked to give 5 points, so we need 2 more. Okay, so which x or y value should we pick? You know what? It's really a personal choice. I don't really care if you pick x values. I don't really care if you pick y values. I'm just gonna go ahead pick y values for fun. Why? Because to solve for x, we're gonna have to square root both sides. So hopefully I can pick a y value that will give us a perfect square. So if I were to pick y equals -3, -3 times 8 is -24, and I have no time to square root 24. Y equals -4, that will give us 32. How about -5? That will give us 40. How about y equals -6? That will give us 48. How about -7? That will give us 56. How about -8? -8 times -8 is 64. I could square root 64 without the use of a calculator. So let's go ahead and use -8. Okay. So when y equals -8, what is the value of x? So we have x squared is equal to -8y. So x squared equals -8 times our y, whatever y we chose, or whatever x we chose, it doesn't really matter. And that will give us x squared equals 64. And after you square root both sides, that will give us that x equals +8 or -8. So when we have y equals -8, that will be associated to 2 different x values. So namely +8 and -8. So again, in my table, I like to circle whatever I picked. You know, did I pick an x value? Do I pick a y value? This is not for credit in terms of you gotta circle. It's just for me, for note-taking purposes. I love speaking to myself. All right, so we have 5 points on the table. So we're gonna have 5 points in the graph. Let's go ahead and graph them, and we're out for this problem. Okay, so the first one is 8, -8. So from the origin, 8 to the right, and then 8 down. Cool. All right, -8, -8 from the origin, 8 to the left, and then 8 down. I think I said it wrong a little bit. It's 8 to the right and then 8 down. And then we're going to do our best to connect these 5 points, making a beautiful, you know, parabola. I can do it right here when I don't have pressure. Okay, I'm going to try my best. I'll just use a highlighter because highlighter is pretty forgiving. Okay. I'm gonna go ahead and do it like this. Put arrows at both ends. Follow the curve. Okay, cool. So remember, we're gonna do our best to do a nice smooth curve. What I do not want to see is a V action going on. Cool, fantastic. So we graph the parabola. We have 5 points. We have the vertex, we have the focus, we have the directrix. We graph the focus, we graph the directrix, so we're good. Now we could stop right here and move on, but actually I want to cover all 4 case scenarios. The one where we open up, down, and then to both sides. So let's go ahead and knock out problem B. So problem B, we are asked to graph x squared equals 10y. So then I'm really not used to writing the equations in this format, so I'm going to cover up the 10 and focus on the variables. So we have y equals x squared. So again, this reminds me of y equals x squared. Okay, so if we have y equals something, then we should have, once again, a parabola that opens up or down. Now in terms of our standard way to write it, you know, we have x squared equals 4ay or y squared equals 4ax. And remember, the question is who gets the 4a. Whoever doesn't have the square, you know, give it some love, go ahead, tag along the 4a. In this case, the y doesn't have the squared, so we're gonna give it the 4a. So bringing it to our paper, we have x squared equals 4ay. So now the question is, what is the value of a? The reason why we need to find a is because that will allow us to find or locate the focus and the directrix. So in this case, we are multiplying y by 10. So in this case, 4a should equal 10. Now, as you can see, the value of a is not going to be an integer. That's okay. You can leave it in fraction form, or you can write it as a decimal. The choice is up to you. Either way, when we isolate the a, after we divide both sides by 4, that will give us 10/4. Last time I checked, when you reduce by 2, that should give us 5/2 or 5/2. Oh, that's not an a. I'm not nervous. Cool. And if you want to write it as a decimal, go for it. Could we write it as a fraction? Sure, be my guest. Okay, so now the question is, what is the vertex? Okay, so the vertex is of the form HK. So in terms of identifying H, I want to know what follows the subtraction sign when I look at the X. What are we subtracting from X? We're not subtracting anything, so H is 0. What is the value of K? It's like, okay, what are we subtracting from the Y? Nothing. Okay, so Y is 0. Okay, so in this case, the vertex is given by 0, 0. Fantastic. So let me go ahead and do my rough sketch. So the question is the parabola gonna open up or down? Because A is positive, then the parabola is gonna open up. Fantastic. Now, what about the focus and the directrix? Since A is 2.5, we're gonna go 2.5 units up. That will be our focus. So that will give us 0, 2.5 or 0, 5/2. The choice is up to you. Now, what about the directrix? So the directrix, we're going to go 2.5 units in the opposite direction, or in this case down. So we have 1, 2, 3, and then we eyeball it. Okay, so let's go ahead and do our horizontal line, and the equation is given by y equals -2.5. So the parabola always opens towards the focus. Okay, or in different words, A is positive, so we pull up. So this is what our graph should look like. Let's go ahead and bring it over here. So our vertex, we already said it's at the origin. The focus is given by 0, 2.5, so we stay put and we go 2.5 units up. Now the directrix, we're going to go 2.5 units down, and then we're going to go ahead and do our horizontal line. Bear with me. Sorry for that long pause, but I'm trying to be neat. Okay, cool. So now the question is, we need 5 points. Okay, the first one comes from the vertex. The remaining 4 are gonna come from your math. The question is, which 4 points should we select? You know, that's really up to you. We're not mind readers, okay? As long as you show me your work, you're good. So let's go ahead and do the XY table. The first thing we're gonna highlight is the vertex. Do you need to put 0, 0? No, but that's how I speak. Now, in order for me to have a good sense of how wide this bad boy is, I'm gonna pick y equals, what was this? 2.5. Okay, so I'm gonna pick a 2.5 for y. The question is, what if you don't want to work with decimals? Okay, then pick 3. Pick whatever you want. So let's do this. So when y equals 2.5, I want to know what is the value of x. So the equation reads, well, let me just put y equals 2.5. Okay, when y equals 2.5, we have x squared is equal to 10y. If y equals 2.5, 2.5 times 10 is 25. So the moral of the story is this: if y equals 2.5, then x will give us +5 or -5. So we're going to have two x values. So it's going to be +5 or -5. So again, I like to circle whatever I picked. Okay, so in this case, from the origin, 5, 2.5. So we're going to go 5 to the right and then 2.5 units up. Other point, -5, 2.5, from the origin, 5 to the left, and then 2.5 units up. And that will make it really nice to see how wide this bad boy is. Now, what about additional x or y values? It's really a personal choice. I'm going to stick with the y's. So if y is 3, 10 times 3 is 30. And when we square root 30, that's not going to be nice. 10 times 4, that will give us 40. 10 times 5, 50. 10 times 6, 60. 10 times 7 is 70. 80, 90. If I pick y equals 10, that will give us a 100. I could square root 100 without the use of a calculator, but 10 is out of our zone. So which x or y value should we pick? You know what? Whatever you want. In order for me to do a really nice graph, I like to put the points that are on the outside. I'm not gonna get a nice integer, so I'll just pick the furthest x value that I can pick. I'll pick -8 and +8. Let's go ahead, pick a +8 for x. If you're like, I have no time for that, then pick +1, 2, 3, 4, 6, 7, whatever you want. Okay, so if x equals 8, I want to know what is the value of y. Okay, so we have x squared is equal to 10y. If x equals 8, that will give us 8 squared is equal to 10y. Square of 8 is 64. And then we keep our cool punch it in or free-handed. And the moral of this story is that if x equals 8, then the value of y as a decimal is going to be 6.4. Let's go ahead and graph it. Okay, so from the origin, we go 8 units to the right and 6.4 units up. I'm just going to say that's about 6.5. No one's going to know if that's 6.5 or 6.4. So if I'm going to pick +8, let's go ahead pick its opposite, -8. So if x equals -8, what is the value of y? Okay, so the equation is x squared equals 10y. I use the equation because it's comforting to the eyes, but then you can just use the axis of symmetry. We're 8 units away from the axis, so when we reflect or bounce it off, we should be 8 units away on the other side. It's really up to you. It just depends how much you remembered from an earlier unit. Okay, coming to our problem. If we get that fifth and final point from our math, then that will give us square of x or square of -8 equals 10y. The square of -8 will give us 64. For the grand finale, to isolate the y, we're going to go ahead divide both sides by 10, and that will give us y equals 6.4. Fantastic. So the moral of the story is that, sorry, I forgot a circle, is that if x equals -8, then the value of y is 6.4. Let's go ahead and graph it. Okay, so from the origin, we go 8 to the left and then 6.4 units up. Okay, I think I'm about there. Cool. So let's go ahead, connect these points and be on our merry way. Okay, let me go ahead, rotate this so I can have a fighting chance to do a nice smooth curve. Okay, go ahead, do it. I should have like music in the background while I do my graphs, but this takes my concentration. So I think it's pretty neat. Nice smooth curve. It's not V-shaped look. I forgot to write down the equation of the directrix. I did it in my rough sketch, but I failed to do it for credit. Okay, so we have y equals -2.5. So we could call it a wrap right here, but I know that you guys want to graph parabolas that open to the sides. Bear with me. Okay guys, fun problem 2 has been located. The directions are the same. Graph the parabola. We want to locate at least 5 points on the graph. We would like a comprehensive graph, so that's why we are asked to graph the vertex, focus, and directrix. And then to make it easier to make sure you nailed everything, I also need you to identify the coordinates of the vertex, focus, and equation of the directrix. So it's the same exact directions as fun problem number 1. We call this fun problem number 2 just to remind us what the directions are, especially since we are on the new page. So let's do this. So let's go ahead, graph y squared equals 6x. So you know my speech, anything that's not x or y is in my way, so let me go ahead, cover it up. And this reminds me of x equals y squared. Let me go ahead, do that on the side. Now, I would love to say that x equals y squared reminds me of a graph that opens either up, down, whatever, but I actually haven't encountered graphing x equals y squared. What I do have knowledge of is graphing equations of the form y equals x squared. Depending on the leading coefficient or the value of a, I know that these will either open up or down. New to our life, we have to have in the back of our mind that if we have x equals y squared, then we're going to have a sideways parabola. So it may either open to the right or it may either open to the left. Okay, Either way, the general form to write the equation of a parabola is going to be given by, by x squared equals 4ay, or y squared equals 4ax. So what I want to point out is this: who is going to get the times 4a? Well, whoever doesn't have a square, that's going to get the times 4a. In this case, it's the x that doesn't have the square, so that's the one that's going to get the times 4a. So let's go ahead and write this in this form. So we have y squared equals 6x. Let's go ahead and write y squared equals 4ax. So we have y squared equals 4ax. Now, it would be nice if we knew what the value of a is. Why do we need a? We need it so we can locate the location of the focus and then the where the directrix is. Now, to find the value of a, this is how it's going to go down. In the original equation, I want to know what are we multiplying x by. So we're multiplying x by times 6. So in this case, in the general form, we have, what are we multiplying x by? We're multiplying it by times 4a. So we are gonna, in order for us to find the value of a, we're gonna take 4a and set that equal to 6. It would be really nice if a was an integer, but as you can see, nice doesn't always happen. So let's go ahead and do this. To get rid of the times 4, let's go ahead and divide both sides by 4. And then it will be up to you if you want to write this as a decimal or go ahead and put it in reduced form. 6 over 4 reduces to 3 over 2, or 3 halves. So you can write a equals 3 halves or a equals 1.5. It's really up to you. Now, in this case, because a is positive, then the parabola, well, we already established that the parabola is going to open to the sides. Because a is positive, then the parabola is going to open to the right. Fantastic. So, you know the speech, how we're going to do it. We're going to do a really rough sketch, and then we'll transpose that to the graph paper and do a more accurate sketch. Okay, let's go ahead, do the XY plane. Now the question is, where is the vertex? So the vertex is given by hk. So h is a number h is a number that follows the subtraction sign for the x, and then k is the number that follows the subtraction sign for y. So in this case, it would have been nice if this is written of the form x minus h, but it isn't. The question is, what are we subtracting x by? Nothing. We're not subtracting anything from x. So in this case, value of h is 0. Okay, what are we subtracting from the y? Nothing. Okay, so this will be of the form square y minus k. Go ahead, look at your notes. We're not subtracting anything from y, so the value of k is also 0. The book that we're currently using focuses on parabolas whose vertex is at the origin, but I just want to be surprised and pretend like, ooh, look, the vertex is at the origin. It's up to you. So let me go ahead, label the origin. We have already identified that the parabola should open to the right. So let me just put vertex, and then I'll put 0, 0. Now, what about the focus? Since a is 3 halves, I'm going to go actually look at the decimal this time around. Since a is 1.5, then to locate the focus, let's go ahead, go 1.5 units inside, because the focus is always inside. So we have 1, 2, and we'll say that the focus is right about there. So 1.5 units later, so that will be x equals 1.5 and y is 0. While I'm at it, let's go ahead, pencil this in, because I don't want to risk forgetting it. We have already established that the vertex is at the origin. The coordinates of the focus is at 1.5 comma 0. Now, what about the directrix? So the directrix will be on the other side. So in this case, because a is 1.5, we're going to go 1.5 units to the left. So we have 1, 2, and negative 1.5 would be right about there. Now, what's so special about this vertical line? This vertical line requires that the value of x always equals negative 1.5. And the only way that's going to happen if we say x equals negative 1.5. Fantastic. Cool. So again, the reason why I like to do a rough sketch is because I feel like this is where I'm not nervous, you know, and if I'm not nervous, then I'm relaxed, and if I'm relaxed, I'm not going to make silly mistakes. So let's go ahead, transpose what we have. So we have the vertex, focus, and directrix. And then we'll do an XY table to facilitate identifying additional ordered pair solutions. So the vertex is at the origin. The focus is at 1.5 comma 0. Let me go ahead and do that. And then the directrix is going to be the vertical line that goes through negative 1.5 on the x-axis. So let me go ahead, take my straight edge and my highlighter. I'm not a big fan of using the highlighter, but it translates a little bit easier on the video. At least I would like to think. Alright, cool. Alright. Yeah, that doesn't look so nice. Maybe I should have stuck with my pen. Okay. Yeah, I should have like music in the background, you know, so we don't have so much white space, but it's okay. It's okay. We don't need music to distract us. Okay, so we are asked to graph the parabola by locating 5 points on the curve. We already have the first one from the vertex. The remaining 4 is going to come from math. We cannot read each other's minds, so it's okay. Highlight any 5 points. So let me just go ahead, put 0, 0 or the vertex. Do you have to put it? No, it's just for my peace of mind. Which x values or which y values should you pick? That is really a personal choice. Okay, I'm going to label it just to highlight why I'm going to pick what I'm going to pick. Now in this case, it would be nice if I have if I had a good sense of how wide this curve is. So for this reason, I'm gonna pick a 1.5 for x. Okay, so when x is 1.5, let me go ahead, circle it, because I want to remind myself that in this case I chose the x value, and if I had chosen the y value, the random y value, I would have circled that. So when x equals 1.5, I want to know what is the value of y. So let's go ahead, write down the equation. So we have y squared equals 6x. So we have y squared equals 6 times x. I really can't multiply by decimal in the back of my mind, so I'm going to write it as a fraction, which was 3/2. If you have easy access to a calculator, then go ahead, put 1.5. But either way, when we multiply 6 by any equivalent form of 1.5, that should give us 9. Okay. When you take the square root of both sides, that will give you y equals +3 or -3. So we have two possible outputs, or two y's. If x equals 1.5, then y could equal 3 or -3. So let's go ahead and bring down that 1.5. So we have the first point from the vertex. The next 2 comes from math. So let's do this. So to graph 1.5 comma 3 from the origin, we go 1.5 units to the right and then 3 units up. And then the next ordered pair, we go 1.5 units to the right and then 3 units down. 1, 2, 3. Fantastic. So we have the first point comes from the vertex. The next 2 points come from the math. Now the question is, what is another x or y value that we should pick? Again, there's no right or wrong answer. It's just up to you. Okay, so this is how I like to do it, because this is crossed out. It doesn't really matter if you pick x values or y values. So sometimes I just like to look at the variable that's being squared. Ultimately, to solve for y, we're going to have to square root both sides. And it will be nice that whatever x value that I pick, it's going to give me a perfect square. So this is how it's going to go down. If if x equals 1, that's going to give us 6 times 1 or 6. Square root of 6, I don't want to work with that. If x equals 2, 6 times 2 is 12. I don't want to square root 12. If x equals 3, 6 times 3 is 18. I don't want to square root 18. If x equals 4, 6 times 4 is 24. Who wants to square root 24? If x equals 5, 6 times 5 is 30. Who wants to square root 30? But if x equals 6, 6 times 6 is 36. I want to square root 36. So let's go ahead and do that. Give me a sec. Okay guys, so we had said that we're gonna pick 6 for x. So when x equals 6, we want to know what the value of y is. So we have that the equation equals is given by y squared equals 6x. Let's go ahead, substitute a 6 for x. So that gives us y squared equals 6 times our chosen x value, which is 36. So if y squared equals 36, when we apply the square root property, that will give us that y equals 6 or negative 6. You know, you square root both sides. So when x equals 6, we have two y values. So if x equals 6, let me circle it to remind me that I chose the x. Do you have to circle it? No. Okay. But when you look at your notes, it's always nice to be like, did we pick the x value or did we pick the y values? You know, it's all about love notes. I love speaking to myself because I love myself. So when x equals 6, the value of y could equal 6 or negative 6. All right, so we have the first point comes from the vertex, the next two come from the math, the final two come from our math. So let's do this. So next ordered pair 6, 6. So from the origin, we go 6 to the right and then 6 up. Oh, this graph paper is too small for me. Next ordered pair 6, negative 6. So 6 to the right and then 6 down. So hopefully I know how to count. Cool. And then if I use my imagination, this will give us a nice smooth curve, kind of like a rough sketch. So again, you don't have to do a rough draft, but it's so reassuring when your actual graph looks like what you planned when you were not nervous. So let's go ahead, do our best to do a nice smooth curve. Let me go ahead, rotate this paper. Okay. So I'm not nervous. Okay. Do the curve. And then I'll start extending it on both sides. Okay, I think I was a little bit overexcited, so I missed the point, but it's okay. I tried my best. Cool. All right. So that's it. So again, we're gonna do a total of not of 4 problems, but not a total of 3 problems, but we're gonna do a total of 3 sets of problems. So this is problem B will be the end of fun problem 2, and then we'll do set 3, fun problem 3, and we're good to go. Okay. Oh, I lied. There's 4 fun problems. Wrong section. Okay. So let's go ahead, graph y squared equals negative 16x. So you know my speech. I'm gonna cover everything that's not the x or y variable. So in this case, the negative 16 is in my way. Okay. This finger is not too wide. I need my my pen or my real finger. Okay, so I'm gonna cover up everything that's not an x or a y variable. Fantastic. And then what I have left is y squared equals x, or if I read it from the variable that's not being squared, that's gonna be x equals y squared. Do we really have to do what I'm doing? No, but it's just easier for me to remind myself. I know that if I had y equals x squared, depending on the value of a or the leading coefficient, it's gonna open up or down. When we have x equals y squared, well, that can be up or down. So by process elimination, it's going to be those sideways parabolas, the ones that open to the right or the ones that open to the left, depending on the value of a. Remember, the standard form of a parabola with vertex at the origin is given by x squared equals 4ay or y squared equals 4ax. The question is, how do I remember this? I really don't. I just remember that we have x equals y squared or x squared or y equals x squared. One of these variables has to have the times 4a. Which one has the times 4a? The variable that's not being squared. The variable that's not being squared is the x, so the times 4a, it's gonna go with the x. Okay, so we have y squared equals 4ax. We have y squared. What should y squared equal? Yeah, it should equal 4ax. So we are going to take our time, work our magic to identify the value of a, so we can then have a fighting chance to find the focus and the directrix. So whatever you're multiplying the x by, that's going to be your times 4a. We are multiplying the x by negative 16, so I guess negative 16 represents our times 4a or 4a. So let's go ahead, take 4a and set that equal to the coefficient of the x term, namely negative 16. Now, for the first time in a while, I'm so excited to report that the value of a is an integer. How about that? Life is sometimes nice. Now, we had already established that in this case, we're going to have a sideways parabola. Because a is negative, then we're going to have a parabola that opens to the left. Fantastic. So let's go ahead do our rough sketch if desired, and if you don't want to, you can go straight just to the answer. Okay, so our vertex. So our vertex is of the form hk. In this case, what is the value of h? So in this case, I want to know what are we subtracting from the x, because you know this should be a binomial of the form x minus h, or x minus a number. For this problem, we're not subtracting anything from the x, so the value of h is 0. What is the value of k? So in this case, we should have a binomial of the form y minus k, or square of y minus k. For this problem, we're not subtracting anything from the value of y, so for that reason, the value of k is 0. Okay, so the vertex is at 0, 0. We had already established that we have a sideways parabola that should open to the left. So let me go ahead, put the coordinates right there, and before I forget, earn our full credit. So vertex 0, 0. Let me go ahead and move this camera. Hopefully it doesn't stop the video. Okay. All right, now what about the focus? Okay, so because a is -4, remember the focus is always like on the inside. Okay, we're gonna go ahead, move 4 units to the left. Okay, so we have 1, 2, 3, 4, and that will give us -4, 0. Okay, let's go ahead, earn our credit. So the coordinates of the vertex is at -4, 0. What about the directrix? The directrix should be 4 units away from the vertex on the opposite side. So we have 1, 2, 3, 4, and that should give us x equals 4. Okay, why do we say x equals 4 versus y equals 4? Well, in this case, value of x has to equal 4, not the value of y. Okay, let's go ahead, earn our full credit. So we have the equation of the directrix is x equals 4. So we did a really good sketch of what's going on. Now let's go ahead, transpose that into our graph area so we can earn our full credit. Let's go ahead, do an XY table to facilitate the process. You know my style. The first point that I'm going to highlight is the vertex. Okay, so let's go ahead, graph it. The focus, let's go ahead, graph it. Why do we have to graph it? We have to graph it because the direction said so. Okay, so we have, where am I, -4, 0, and the directrix is given by x equals 4. So let me go ahead, take my straight edge and do my vertical line, cutting through the x-axis at 4. I feel like I should say like a joke or something, you know, during that moment of silence, but yeah, no, you don't want to hear my dad jokes. They're too played out already. Fantastic. All right, cool. So let's go ahead, do the math so we can get additional 4 points. Why? Because it's a 5-point minimum. The first one comes from the vertex, and the remaining 4 are gonna come from the math. Okay, so what x values or what y values should we pick? There's no right or wrong answer. That's the nice thing. You just gotta make sure that whatever points you pick, they are in this graph paper. The axis is already set to the scale. The scale is already set to 1 on both the x and y axis. So if we run out of space, we do not have the liberty to adjust it. For me, it's always nice to have a sense of, let me go ahead and extend it. It's always nice to have a sense of how wide this parabola is. So for that reason, I'm going to pick either the x value or the y value, depending if the parabola opens to the sides or if it opens up or down. So I'm going to pick the x value. To be more specific, I'm going to pick x equals -4. Okay, why? Because that will allow me to really see how wide or narrow this parabola is. So when x equals -4, I want to know what is the value of y. So again, I circle whatever I'm picking. So that way I remind it like, oh yeah, for this problem I picked the x value. For this problem I picked the y value. So if x equals -4, I want to know what is the value of y. So the equation, if we can read it, reads y squared equals -16x. Let's go ahead, substitute -4 for x. So we have y squared equals -16 times x, which is, in this case, is -4. Product of -16 and -4 didn't come prepared, is 4 with the 2. 4 with the 2 plus 4, sorry, 64. Okay, remind me to have my answer key in front of me next time. So I believe that's correct. When we square root both sides, that will give us that y equals 8 or -8. So we're going to have 2y. So when x equals -4, y could equal 8 or -8. But let's go ahead, bring down the x again so we don't forget. Okay, so let's go ahead, graph them. So we go 4 units to the left. Where am I? And then 8 units up. Oh, we barely touched it. We barely fit. Cool. And then other point, -4, -8. So from the origin, 4 to the left, and then 8 units down. Now, what other x values or y values should we pick? In this case, because we have a sideways parabola, I'm going to continue picking x values unless I don't have space, and then I'll pick something else. Okay, so I want to point out how the parabola is looking. It looks to be really wide. If I pick x equals -5, I don't know, I think I'll be out of bounds. Okay, but either way, I'm just gonna start counting back from 1. Well, to be more specific, x equals -1. If x equals -1, if we pick a -1 for x, that's gonna give us -1 times -16, and that will give us 16. I could work with 16. Why? Because to solve for y, we're going to have to square root both sides, and I would totally love to square root 16. So let's go ahead. What was that? -1. Cool. All right. So I need a break. So when x equals -1, I want to know what is the value of y. So we have y squared equals -16 times x. Y squared equals -16 times the chosen x value. And the question is, what if we didn't have a nice value what if the value of x that we picked didn't allow us to have like a nice value for y? Like if we had picked -2 for x. If you had picked the -2 for x, that will give us y squared equals 32, and then you would just approximate the value of y. It's no big deal. Okay, yeah, okay, I think I made a big deal out of it, so I'm gonna stop right there. Okay, product of -16 and -1 will give us 16. And if we have y squared equals 16, then that will lead to a solution of 4 or -4. Cool. All right, so when x equals -1, we're going to have two possible y values. We're going to have a +4 and a -4. So I'm going to rewrite the -1 over, because then I'm going to confuse myself if I don't. Let's go ahead, locate the final 2 points for a grand total of 5. So the next one up is -1, 4. So from the origin, we go 1 to the left and 4 units up. The final one, -1, -4. From the origin, 1 to the left and 4 units down. So if we use our imagination, and when we connect all our 5 points, look at that beautiful parabola. It matches our description. Okay, so let me go ahead and rotate my paper. Again, I want to have a fighting chance. Okay, my fake finger's in the way. All right. Who has a joke? Yeah, not me. This requires my total concentration. Okay, so we graphed it. We have 5 points. We located the focus. We located the vertex. We located the directrix. We gave the directions. We gave the coordinates of the vertex, focus, and equation of the directrix. That's it. We're on our way to earn our A. So we were going to do a total of 4 fun problems. This is fun problem number 2. Give me a moment, and then we'll do the final 2. Thanks. Okay guys, so the final 2 fun problems have been located. Let's go ahead and knock them out, and that'll be the end of the day. Okay, so fun problem 3 reads, find the equation of a parabola with the origin as its vertex, the x-axis as its axis of symmetry, and 4, -8 on the graph. Okay, this is a lot of information, so it's really hard for me to read this and just be like, boom, let's go ahead and do the algebra. I need to sketch what's going on. Okay, so what do we know about this problem? So we know we have a parabola. That's nice. It may open up, down, or side to side. We know that the vertex is given by the origin, so let me go ahead and write that out. The x-axis as its axis of symmetry. Okay, we know the axis of symmetry. What is the axis of symmetry? It's going to be the actual x-axis. I'll touch base on that in a bit. And 4, -8 on the graph. Okay, let's go ahead and bust out the graph paper. Give me a second, someone is calling. Okay, so the vertex is at the origin. And then the question is the parabola gonna open up, down, or side to side? Well, we have that the axis of symmetry is given by the x-axis. So the x-axis is horizontal. So the parabola is either gonna open to the right or it's either gonna open to the left. Okay, that's what they're telling you. Okay, now what do we know? We know that so we have a sideways parabola. We also know that 4, -8 is on the graph. So let me go ahead quickly locate 4, -8. And this is what I mean by quickly. We're not going to do 4 tick marks. We're going to do 1 tick mark to represent 4 and then 1 tick mark to represent -8. Okay, let me go ahead, put 4, -8. Given that the x-axis is the axis of symmetry, we have already established that we have a sideways parabola. Okay, so the parabola is either going to open to the right or to the left. Given that we have 4, -8 on the graph, let's go ahead and do our sideways parabola, making sure it goes through the 4, -8. And then with confidence, we can see like, oh yeah, we do have a sideways parabola. And in this case, the parabola opens to the right. So how is it going to go down? So the question is, what's going to be the equation? Is it going to be x squared equals 4ay? Or is it going to be y squared equals 4ax? I would love to say, bam, this is what it's going to look like. But this is hard for me to remember because this is a new format. For me, what I have in the back of the mind is from like the beginning of the semester, y equals x squared. So if we have the square on the x, the parabola is going to either open up or down. New to my life, if I have x equals y squared, I should have done that over here. If I have x equals y squared, by process of elimination, if I have the square on the y, I can't have a parabola that opens up or down. We're going to have a parabola that opens to the side, either to the left or to the right. Okay, so in this case, we have to use the one where we have the square on the y, or this one. Okay, y squared equals 4ax. So we have a sense of what the equation should look like. Now what we need is, what is the value of a? They don't give us the focus, so let's go ahead, substitute this the coordinates of this point given. Okay, so we know that the equation has to be of the form y squared equals 4ax, and we're gonna go ahead, pencil in what we know, which is this ordered pair, 4, -8. So with your permission, let's go ahead, substitute a 4 for x and the -8 for y. So we have y, which in this case gives us -8. We are going to square it and set that equal to 4 times a. We don't know what a is, but we do know what x is, and x is 4. Fantastic. Let's keep our cool and solve for the variable that we see. The square of -8 is 64, and that should equal to product of 4 and 4 will give us 16 times a will give us 16a. We take our time to get rid of the times 16. Let's go ahead, divide both sides by 16. Who has a calculator? I believe the quotient is 4. If it's not, then I'll update the video later. Okay, so we had already established, that the equation should be of the form y squared equals 4ax. We know what the value of a is. We have that a equals 4. So we have y squared equals 4 times a, which is 4 times x. And after all that hard work, we have that y squared equals 16x. And you can check it. Just make sure that 4, -8 is a solution. Okay, so we are going to do a total, we are going to do a total of 4 fun problems. So hey, we have come to the end of this video, unfortunately. Okay, so fun problem number 4, the directions read, find the equation of a parabola with vertex at the origin, axis of symmetry, the x or y axis, and the following. Okay, So for all of these three problems, well, let me go ahead and write down the first problem. Okay, so we have that the focus is given by 0, -5. So for all of these three problems, find the equation of a parabola with vertex at the origin. So let me go ahead and highlight that. Vertex at the origin. Axis of symmetry, the x or y axis. Okay, so that's saying that we're either going to have a parabola that opens up or down or side to side. And for this problem, focus is 0, -5. It would be really nice if I can just say, with this information, this is my equation, but that doesn't really work for me. You know the drill. I gotta sketch it. Okay, so first things first, I'm gonna go ahead, locate the vertex. The vertex is at the origin. Cool. The focus is 0, -5, so we stay put and then we go 5 units down. You know my style, I just put one tick mark, and then whenever I don't put like all the tick marks, then I do label the coordinates. So we have 0, -5. While I'm at it, I'll label the coordinates of the vertex. The question is, let me go ahead and zoom in because this is too small. The question is, what is the distance between the vertex and the focus? Okay, the distance between the vertex and the focus is 5 units. Okay, so in this case, now remember the focus, no matter if the parabola opens up, down, or side to side, the focus will always be like on the inside of the curve. So we shall have a parabola that opens down. So the question is, what is the equation gonna look like? You know, is it gonna be x squared equals 4ay or y squared equals 4ax? So I'm gonna just start from scratch. Okay, so if we had y equals x squared, you know, depending on the value of a, we're gonna open up or down. If we have x equals y squared, new to our life, we're gonna have those sideways parabolas. Okay, in this case we have a parabola that's going down. Okay, and if it's going down, that means that the value of a is negative. So because the distance from the vertex to the focus is 5 units, we know that there's a 5 involved in the value of a, but because it's going down, it's going to be -5. Now for our equation, so remember, one of these two variables has to be multiplied by the ay, and in this case we are multiplying, whoever doesn't have the square, that's gonna have the ay. So this is gonna give us a 4ay equals x squared, but to make the book happy, we'll put the x squared on the left. Okay, so let me go ahead highlight this. So if we put the x squared on the left, we have x squared equals 4ay, and let's go ahead pencil in what we just found out, that the value of a is -5. So we have x squared equals 4 times the recently found a of -5, and then we gotta multiply it by y. So when we keep our cool, product of 4, -5, and y will give us -20y. And thanks to your hard work, we have that the equation of a parabola with the vertex at the origin, focus of 0, -5, axis of symmetry, the y-axis. What is the equation? Just like that, it gives us x squared equals -20y. Let's go ahead and knock out problem B. So problem B, what do we know? We know that the directrix, let me go ahead and write it out. The directrix is given by the equation x equals -9. We know that the vertex is given by the origin, and then one of the two axes, either the x-axis or the y-axis, is going to be the axis of symmetry. Let's go ahead sketch what we have, and then we'll see if it's the x-axis or the y-axis. Go ahead, do the xy plane. Do you have to do this? No, you know what, you really don't. It's just, for me, it's really hard to be like, what's gonna be the equation? Is it gonna be x squared equals 4ay, or y squared equals 4ax? And I've said it before since day one. I memorize what I have to, and I understand as much as I can, leaning on the understand as much as I can. So the reason why I do things the way I do is because I feel like I only have to remember one thing. What is A? Oh, A is the distance between the vertex and focus. And then I'll let my sketching do the math. So let's do this. So the vertex is given by the origin. Why? Because the problem said so. Okay. The directrix is given by the equation x equals -9. So that's going to be a vertical line. And if you don't have that in the back of your mind, do an XY table and let the table speak. Okay, so let's go ahead quickly locate -9 on the x axis. And you know my style, when I say quickly, it means you put one tick mark and then you mark your territory. So we have established that we should have a vertical line. I'm going to go ahead and put this for my peace of mind. So now the question is, what is the distance? Well, scratch that. So the question is, how is the parabola going to open? Is it going to be up, down, or side to side? Well, the directrix is on the opposite side of the vertex. Okay, so the focus should be on this side. So let me go ahead, label what I was going to do. The directrix is 9 units away from the vertex. So that means that the focus should be 9 units away as well. So the focus is always on the inside of the parabola. So in this case, we will have a sideways parabola where the parabola opens to the right. What are the coordinates of the focus? When we go 9 units to the right, that will give us 9, 0. I don't think you need this, but I'm an overachiever, so I label things. So because we have a sideways parabola, you know, what's going to be the equation? It's not going to be the one that looks similar to y equals x squared. It's going to be the one that reminds me of x equals y squared. So the question is, who's going to get the times for a? Whoever's not being squared, that's the one that gets it. So it's going to be 4ax equals y squared. Why am I tagging up this solution? It's okay, we can borrow it. Okay, so the equation should be of the form 4ax equals y squared, or you know, let's make the book happy. We'll put y squared equals 4ax. But now the question is, what is the value of a? We know that the distance from the vertex to the focus is 9. Okay, so we know that there's a 9 involved. But now the question is a not going to be positive or negative? Because the parabola opens to the right, then the value of a will be positive. So it's going to stay as positive 9. Let's go ahead, pencil in what we know. We have that a equals 9. So that will give us y squared equals 4 times a, which is 9 times x. And last time I checked, product of 4, 9, and x will give us 36x. So thanks to your hard work, we have that y squared equals 36x. Now, for the grand finale, problem C was a bonus problem. So I would usually say we do it if we have time. Guess what? We have time, so I made it a regular problem. Problem C, we have that the directrix is given by the equation y equals 4. We know that the vertex is at the origin, surprise, and either the x-axis or y-axis is going to be the axis of symmetry. Once we locate either the focus or the directrix, then we will know if the axis of symmetry is the y-axis or the x-axis, and that will facilitate what equation to use. Okay, so let's go ahead, sketch this, and we're out. So we have the xy plane. Let me go ahead, locate the vertex. Cool. The directrix is given by the horizontal line y equals 4. And if you're like, oh man, I don't know if it's vertical or horizontal, excuse me, go ahead, do an XY table and the math will speak to you. So we have a horizontal line that should cross the y-axis at 4. So you can do your 4 tick marks, but you know my style, I just do 1 and mark my territory. So let's go ahead and do that horizontal line. Cool. And then what do we notice? Let me go ahead, zoom in, because this is too small for me. We have that the directrix is 4 units away from the vertex. So let me highlight that distance. So if the directrix is 4 units away from the vertex, excuse me, if the directrix is 4 units away from the vertex, then that means that the focus should be 4 units away as well. In this case, it will be, sorry, I'm not nervous, you're nervous. Okay, I meant to put the -4 here and then pencil in the -4 thereafter. Okay, yeah, this is just, yeah, I should just start this video again, but it's okay. You understand me, okay? Why am I putting -4? I feel like I'm in one of those movies when, like, you know you're falling and you just can't stop yourself. Like, you just gotta keep on falling. Okay, I fell. Okay, so I'm never gonna be able to bounce back from this, no matter how bad I try to fix it. Okay, so let me redeem myself by saying it verbally. Okay, the distance between the directrix and the vertex is 4, so the distance between the vertex and the focus should be 4. I meant to put positive 4 here. I got a little bit nervous because I was trying to do 2 things at once. When we go 4 units down, that will bring us at y equals -4. In terms of the coordinate, x is still 0, and now y is -4. Okay, so I redeem myself a little bit. Cool. So again, the focus is always on the inside of the parabola. So in this case, we have a parabola that opens down. Okay, I love parabolas that open up or down because I feel like I'm back home. So this parabola is going to come from y equals x squared. You know, parabola may open up, parabola may open down, depending on the value of a. Okay, because the parabola is opening down and the value of a needs to be negative. We know that the value of a involves a 4. Why? Because the distance from the vertex to the focus is 4. Now, because the parabola opens down, then that means that a has to be negative. Cool. Now, what should the equations look like? Who's going to get the times 4a? Whatever is not the variable that's not being squared, that's going to get the times 4a. So we're going to write down 4a times y equals x squared, but we want to make the book happy, so let's go ahead and put x squared first. Why don't I just jump straight to x squared? It's because I'm trying to minimize the things that I memorize. I remember this, and then from this I can just manipulate it to that, and that way I don't have to memorize 2 separate things or 3 separate things. So it's a personal choice. Let's plug in what we know. So we have a equals -4, plug in the -4 for a, and we're out. So we have x squared equals 4 times a, value of a is -4, and thanks to your hard work, we want to tell the reader that the equation of a parabola with directrix y equals 4, vertex at the origin, the y-axis as the axis of symmetry, that equation is given by x squared equals -16y. Okay guys, so I said we were going to do a total of 4 fun problems. I know it was more than 4, but it's for your own good. You'll thank me later. Cool. Okay guys, that's my time. We're out.